What up, dudes? Welcome to algebra class. I don't know why I start every class like that. And I even apologize for not knowing why I start every class. And I apologize every class, don't I? How's it going? Algebra 2 class. I've got some good news and bad news. You want the good news?
Let's start with the bad news first. So let's start with the bad news first.
Okay. Well, I'll start with the good news. The good news is I just said good news and bad news, but to be honest with you, I have no idea what the good news is. The bad news. The bad news is this. I've been giving you folks lots of breaks, haven't I? Right? I've been pushing these assignments back and saying, okay, well, I'll tell you what, let's just move that back a week. Here's the thing I realized. We need to get through chapter 5 by the end of this quarter. And if we need to get to chapter 5 by the end of this quarter, we need to finish chapter 3 homework, like I think this week or next week or something like that. Then chapter 4, then chapter 5, and that's it. We don't have any time to push anything back. So I apologize, but you guys might feel an onslaught of homework coming on, and that's because I kind of pushed everything else back. I will be as accommodating as possible. In fact, now that I'm saying this, now that I'm thinking about this, remind me after class today or sometime today, because I have chemistry lab right after this, but sometime today, remind me to up your tries to like 3 tries. And I'll tell you what, I'll up your tries from 3 tries, I'll give you 5 tries this time. And I'll give you like 2 weeks after the due date to turn it in. The reason why I don't usually do that is because a lot of times you folks procrastinate. But now I can tell you, don't procrastinate, and you won't procrastinate, right? Right? Because you folks have been procrastinating, and what I've been doing as a result of that is pushing everyone's assignment back to give you more time, and then that's giving everyone some breathing room, but the problem is that got us in this pickle.
You take all the breathing room.
What is that?
The problem is,
we took up all the breathing room, and now we don't have any breathing room to like play around with. So now, if you folks email me and say, hey, Mr. Dolde, I need more time on this assignment, can you push the due date back? I'll say, no, sorry. All right. Anyway, that being said, we got to get started on lecture on chapter 3. I think it's chapter 3. I think that's where we last left off. It's been a while since we talked about math. Can you folks see my face?
Yes.
Can you hear my voice? Of course you can. And you can see my face too, and hear my voice. All right. Then what we will do, wait, I want to do this. I want to go back here. Then I want to do this, and I want to open up this thing. I'm going to switch back and forth between these 2 screens. So let me just open this up and go to home. I'll make it bigger. I see everyone going like this because they can't see. All right. All I'm doing is I'm opening up chapter 3. I want to see where we're at with that. I think that I did 1 lecture on it. I think I even got pretty far into it. Yeah, I did 1 lecture. I archived it already. That was way back on 9/2. We didn't have class since the 2nd. That seems wrong. Did I forget to archive something? We had class last week, Wednesday, didn't we?
Yeah.
What was that? Was that the 2nd? Today's, oh yeah, it was.
Yeah.
The last time we had a class was a whole week ago. Yes, because of that thing on Friday. Yeah, all right, so the last time I lectured was on this. So let's download this. Let's open it up. And we're ready. Let's see how far I got on this one. I forgot already. All right. Oh. Sorry, I've been running around working really hard. How is math class? It's not so bad now? All right. So we talked about parabolas, didn't we? We talked about matching the parabolas, and we talked about how these are the 0 points, right? And the number out in front, that's like your A value, so it tells you whether or not your parabola is vertically stretched or vertically compressed, and whether or not it's flipped upside down or right side up, it's a happy or sad face. We know all this stuff already, right? And that's for the number out in front, like this 0.5 or this -1. Good. All right. Then we did that. I know we did this. Today I think what I might be able to do is just get through chapter 3 and chapter 4 and just do a lecture on that. All right? I'll tell you what. I'm going to go as quick as I can, and I want you to stop me if your brain hurts. All right? Slow me down, but I'm going to go fast. Let's see. Is this? Oh, this is a part of your homework, so I can't tell you this stuff. Actually, you know what? Sure.
Can we go over 3.4?
Oh, 3.4? Oh, 3.4 is your homework.
Yeah.
All right, here's 3.4. For what values of C does the graph have two intercepts? So, you folks are like, sweet, he's going to do part of my homework for me. All right. What does C do? Let me write it down. Y equals ax squared plus c. It's not mx plus b, it's ax squared plus c. Remember, we're dealing with parabolas this time. Back when we were dealing with lines, it was mx plus b. What does c do? It takes that parabola, pushes them up, or pulls it down. Good. So, if my parabola got pushed up, how many x-intercepts does it have?
0.
Don't got none. Does that make sense?
Yeah.
If my parabola, so if I have a regular parabola, and if that guy got pushed up, how many times does it cross the x-axis? It crosses 0 times. You understand that, guy? Good. And I apologize. I'm going to apologize up front. Don't feel like I'm picking on you, but I might be calling on you to say, do you understand? I just want to make sure, because the last I heard, you told me that you were lost.
Oh, yeah, no worries.
All right. So,
I don't care.
everyone in the class, she's not dumb. I'm just asking her if she understands, okay? Don't tease her, or I'm going to start picking on you. All right. Now, if I take this parabola and I pull it down, what happens? 2. So the question is, for what values of C does this parabola have two x-intercepts?
Less than 0.
Anything that's negative. Anything that's smaller than 0. 2 intercepts. Or I could ask, for what values of C does this parabola have exactly 1 intercept?
0.
If C were 0, I'm not pushing this thing up or down. It's a regular parabola. Even if I change A, it only touches the x-axis at one point. If I change A, it might flip it upside down, or make it skinnier, or make it fatter. But it's still going to only have 1 intercept. Cool? All right, good. So that would be the answer to, I think, 3.4 part 1, or something like that.
Yeah.
Yeah, I think that if you understand what we've been talking about, 3.4 shouldn't be so bad for you. Was there a question you had specifically that you wanted to do or talk about?
I got the C thing around, for if A is negative for 9 C.
Okay, all right. We'll do that.
But it's still, that one is still, if C is less than 0.
How do you graph a parabola? How do you graph a parabola? Is that what you're asking me, Bradley? All right, good. Is somebody else on? Are you online? Nobody else? You can jump back online. I know I told you to get offline, but you can jump back online, and you can. The font over here is so small I can't even see what they're saying. So can you make sure to relay their questions online to me?
Yeah.
All right. How do you graph a parabola? That's a perfect question. That's actually what we're doing. That's all we've been doing for the chapter 3. In fact, I hate to say it, but chapter 3, 4, and 5 is going to be the same deal, graph a parabola. All right? So right now, the way we're graphing parabolas is I think we're looking at the factored form. Okay? It's going to look something like, I don't know, ABC, D plus X, or I'm sorry, X plus D and X plus E. And there's an A. This is the standard form. This is the factored form. Now the factored form has it looking like this. And these tell you, what does this information tell you? Real quickly. You can immediately find where the x-intercepts are. Now in this particular parabola, even though it's something a little weird, what are the x-intercepts? I want to see if you can figure that one out.
Negative
Close.
D and negative E.
Negative D and negative E. It's the opposite sign of what's in here.
Yeah.
Right?
Mm-hmm.
And then this A tells you whether or not it's vertically stretched, vertically compressed, or flipped upside down. For now, that's all I've taught you as far as graphing problems. I've taught you a little bit of this stuff right here, and mostly this stuff.
So,
Are we cool? Now your question.
So if A is negative, C
So
is still...
So going back to 3.4 homework, I think that what the question is asking is,
Yeah.
if A is negative, what does negative A do?
Just flips it upside down.
So we're talking about a parabola who starts off like this. Is it still true that if C were negative, this has two intercepts?
Yeah. Yes, but also if it is greater than 0.
Only if it's negative or positive.
He's got it. You don't. But I'm going to say this. He's got it, and you have it correct too. Why don't you folks argue about it? But then you already know that you're wrong because I already said he's got it. All right. Exactly. If it's upside down, and I take this parabola and I move him down, if A and C are both negative, then is this going to have two intercepts? No, the only way this thing can have two intercepts, what I mean by intercepts is when this thing crosses the x-axis. That's what I mean. We good? All right. The only way I can have that is if I take this thing and I pull it up.
Which one is standard form?
Standard form is this one on the bottom. Technically, this is standard form. And I think the last time we met up on Wednesday, I gave you a little like simulation that you got to play with to see what that B parameter does. You know what I mean? Like it didn't. The C moves it up and down, and we're cool with that. The A is something we've talked about extensively, and then the B, everyone says, "Oh, it moves it right and left," and I'd say, "Well, it kind of doesn't actually. It kind of does and doesn't at the same time." But don't worry, moving it right and left, we're going to look at a different form, and that might actually be a lot easier for us to understand. All right, let's see what else the text has in store for us. Does anyone know any hotkeys as far as switching apps? I wonder if it's Shift Tab. Control Tab? No, this is to switch the tabs. Where's Control W? No. All right. Okay, so this is still homework 1. This is still homework 1. Solving equations. This is pretty cool. Let's solve this equation right here. All right, let's do it. I think it's this equation right here. I'm going to write it down. I don't know if I covered this with you. 2 times x plus 3 times x plus 5 equals 0. Oh, x minus 5. And let me just show everyone the, there we go. Can you folks online see it? See that? And that's minus. Can you see that? Okay. What is that?
Is this like the completed square thing?
No, this is not completed the square. This is much easier than completed the square. First thing, I want to get x all by itself. I'm going to take this 2, I'm going to divide it onto that side. Cool? So I divide both sides by 2. That kills that 2, and it puts 0 over 2. The 0 just kills that, right? So it's just 0 on the right-hand side. So I have x plus 3, x minus 5 is equal to 0. Very cool? What are the answers? Negative 3, positive 5. You can immediately see that. Boom. Sky. Do you see how we got negative 3, positive 5? You sure? All right, good. Anyone else? Confused about that online? All right, good. Okay. What about this? X squared minus 25 equals 0. Can you tell me the answer without me doing that? What did they say?
5.
You say 5. Awesome. Anyone else? 5? Cool. Everyone online? 5? Are we good? Can you see this immediately? 5. Boom. I look at this. 5. Ha ha! She beat you. You were only half right. Check this out. I'm going to take the 25 over to the other side. X squared equals 25. I need to take the square root of x to get it to be just x, right? I want to get rid of the square part, so I got to square root it, unsquare it. So if I square root this side and I square root this side, there's a rule that says whenever you take the square root of both sides, you have to throw in a plus or minus. Have you heard of that rule? Do you understand that rule? Well, think about this. If you plug in positive 5, that works. Because positive 5 squared is 5 times 5, which is 25. But if you plug in negative 5, that also works because negative 5 and negative 5 times each other is positive 25 as well. Does that make sense? Would you like to see this almost in a visual sense that will kind of blow your mind and say, oh, I understand. It's way easy as to why there's 2 answers.
Okay.
No, I don't want to see it because I don't want to learn anything. All right. If I were to graph this, say I replace this 0 with a y. If I were to graph this, by knowing what you know, can you tell me, how would this graph? What would I do? Yeah.
The C would be
The C is the thing that doesn't have an x by it.
Yeah.
And so what is that negative 25 doing?
It's moving it's pulling the.
I take that whole
upward-facing
parabola and I pull that sucker down. How many times would I pull it down? 25 units. Are we cool? It looks something like that. Where down here is negative 25. Are we cool? What are the x-intercepts? Both positive 5 and negative 5. Because when we have an x squared, we're dealing with a parabola. When parabolas have answers, they usually have 2, 1, or 0 answers. In this particular case, we have 2 answers. Notice the plus or minus 5. It's right here. Why is there 2 answers? Because the parabola crosses at 2 x-intercepts. Good? All right, good. So don't forget to throw in a plus or minus when you are solving, taking the square root of both sides. Let's see. Ooh, this one's good. This one's actually pretty easy. Actually, I'm not going to do that one. Sure, I'll do it. Let me write this down. So make sure you write down all of the stuff that I'm writing down on the board. F of x is equal to 3 times x minus 4 times x plus 1. Parentheses. Bring it to the board. Can you folks see this? 3 times x minus 4 times x plus 1? Yes, no, okay. What form is this in? What form is it in right now? Factored form. It's not in standard form. Standard form looks like this. Does that look like that? No. How can I get it into factored form or standard form? It's very easy. Just yeah, you just multiply the whole thing out. And in this case, we call that FOIL because we've got 2 parentheses that we're dealing with. Can I FOIL this quickly, or do you guys need me to go over FOIL? FOIL? All right, okay. You shook your head? No? Okay, good. All right, just making sure. So, x squared minus 3x plus, or minus 4. And then I covered that up so to remember I still have to multiply the whole dang thing by 3. So I have 3x squared minus 9x minus 12. This is the equation in standard form. So I can take something that's in factored form and easily convert it into standard form by just doing what? Foiling. Very good. Can I go backwards? Could I take it from here and bring it back to here? Sure. And that's called factoring. Good? All right.
Factoring is a little tedious.
Factoring is tedious. I like foiling way better than I like factoring. But you need to be able to do both. Ooh, factorable quadratic equations, which basically means this thing, they're going to show us they're going to show us how to factor things. Do you folks remember how to factor things? All right. To be honest with you, I almost feel like factoring is just a matter of practice. And I hope that your Algebra 1 teacher made you do like 100 factoring problems. Because that's the only way to get good at this. And I hate to say this, I know that you folks would be really bummed out about it, but I'm not going to make you do 100 factoring problems because we don't have the time. But if we did have the time, I totally would make you do that, and I think that you'd be very pleased about that. Let me write down some problems on the board. Bradley, I'll go over some factoring with you. I'll basically do the basics, all right? How are we doing with that, Sky? Are you factoring? How's your factoring skills? Gee, you don't even remember. I don't even know where you're starting. All right. Plus 11x plus 24. Is that it? Plus 24?
Don't you need a number that, like, when added, it equals 24 and
All right. Let's see. What is the best way to teach you factoring? How do you folks feel about factoring? Because I feel like I would just kind of go over it real quick. But if you folks don't, if a lot of you are saying, I'm scared about factoring, I can give you the quick lesson off the top of my head.
Yeah, I would like.
All right, fine. Okay. Let's start a little bit before. All right. I'm going to start with the theory of it. Okay. And just watch this for now. You can take notes, but watch this. X plus A times X plus B. I'm going to FOIL that. No one's afraid of foiling, so we'll do it. X squared plus BX plus AX plus AB. A times B, that is, right? Then I'm going to do this. X squared plus AX plus BX plus A times B. Are we cool with that? All I did was I switched these around. I'm allowed to do that because it's addition, right? I'm going to do something weird. X squared plus A plus B times X plus A times B. All I did was I pulled out an X out of this middle one. If you distribute this thing back in there, you'll get exactly the line above it. Is there any arguments against this?
How did you get there?
How did I get here?
Yeah.
Well, I got here from here. I got there from there, and I got there from there. Okay, no. I noticed there was an X in both of these.
Oh, I see.
So I just pulled out that X,
Okay.
just to kind of make it easier for me to see. Because this is kind of the standard form, right? This is the X squared, or AX squared plus something times X plus something else that doesn't have an X in it, right? So check this out. Here's what I want you to notice. I want you to notice that this last term right here, this last term, if I gave you numbers, like, let's pretend, I don't know, let's say that A is 3 and B is 4. So this would be X squared plus 7X plus 12. Because I let A equal 3 and B equal 4. We cool with that? And 3 plus 4 is 7, and 3 times 4 is 12. We cool? And putting that back to our factored form, what did I say A was? 3, right? So it's X plus 3 and X plus 4. So apparently these two are exactly the same. Right? I want you to notice, and usually what I do is I'm going to give you this, and I want you to find this. But I want you to notice that the two numbers that are here, if you multiply them together, you'll get this number. And how do I get this number? You add these two numbers together. Are we cool with that? Everyone online, or are you afraid now? Like, nothing I've done has made you afraid yet. Okay, all right, fine. Okay, I won't erase it. All right, I'm going to erase it. So they had that one problem, x squared plus 11x plus 24. Okay. I have to solve this problem. I'm going to make my big parentheses, okay? I'm going to put an x here and an x here, and I know that there's going to be a symbol or a sign right there, which means there's going to be a plus or minus. I don't know yet. There's also going to be a sign, a number right here. So there's a sign right here and a number right here. The signs are pretty easy to find, but the numbers is kind of what the game we're going to play. What are some candidates that I can choose for this 3 and 8? 3 and 8 won't work. The reason being, because 3 times 8 is not 12. And actually, I think that there was supposed to be a negative out in front here. I'm sorry. There's a negative. All right. What other candidates can I choose from? What two numbers multiply out to 12? 2 and 6. That's a good one. 2 and 6 multiplies out to 12. Good. Anything else? Online? Come on. 3 and 4. Awesome. 3 and 4 is good. Any other candidates? Any other numbers that I can multiply together to make 12? That's the best one. I love that one. That's the one I don't have to think about. 12 times 1. Are we cool? Now, I need to choose one of these 3 pairs, and I need to choose it in such a way that I can either add them or subtract them in some kind of weird combination so it makes negative 11. Which one of these can I add up together or subtract? 12 minus 1. Close. That makes positive 11. And actually, I'm sorry. I think there's supposed to be a negative out right here. I think I screwed this problem up when I wrote it down. All right, what did you say? 1 minus 12? Or, yeah, 1 minus 12. So, positive 1, negative 12, right? So, I'm just going to try this. Positive 1, negative 12. I wonder if that works. Oh, oops. No wonder I screwed up this problem. I was trying to think in my head, what's going on? All right, I'm sorry. I wrote down the problem wrong. So it's a totally different problem now. All right, let's deal with it. I wonder if that works. And like I said, the best way to learn how to do this is to do a whole lot of problems. The reason being is because it gets you really good at guessing and checking. And you should be able to FOIL like nobody's business, right? So, FOIL this. FOIL that and tell me if I got it right. FOIL it up. I'm not going to do it for you on the board because like I'm saying, you should be able to FOIL nobody's business. So FOIL that, tell me if I got the right answer. I want to see everybody writing something down with a pen or pencil. Preferably on a piece of paper and not the table. It works? Awesome. Awesome. Let's try another one. Ethan is saying he was confused. Look, I wrote down the problem one wrong. It's x squared plus 11x plus 24. Okay. Okay. Let's do another one. Sorry, I wrote it down wrong. It was x squared plus 11x plus 24. Let's do that problem. All right. What are my candidates? What? 3 and 8. Good. No wonder you were so confused because I had the wrong numbers up there, huh? What else are my candidates? 6 and 4. I like that one. What other candidates do I have that will give me 24? Yeah. 24 and 1. Chris gives that's called the low-hanging fruit. 24 times 1. Very good. I like it. Anything else? I can think of one more. 2 times 12. All right. Here's the problem we have. Can I mess with 2 and 12 and by adding them in some weird combination to get positive 11? No. What about 24 and 1? No, I could get 25. I could get 23 maybe. I could also get negative 25 and negative 23, but not 11. Not even anywhere close. What about 6 and 4? I could go with 10, or if this were 2, this might be a good candidate, right? But not 11. This is my only option. 3 and 8. Should I just add them? Shoots, add them. X squared, or x plus 3, parentheses, x plus 8. And you want to know the best gift of all? Is if I gave you this on a test, you can check whether or not your guess is correct. How do you do that? You FOIL it out, see if it works. We cool? Let me show you some of my tricks. Now, ideally, you would pick up these tricks ideally you would pick up these tricks after doing 100 problems. But I'll just show them to you now because I hope that you would have done a lot of these problems back when you were in Algebra 1. I'm going to try something else. X. What are the numbers going to be? They're going to be the same numbers, right? But the reason why they're the same numbers, but the problem is, because the other numbers wouldn't get me anywhere close to 11. So I know that it's got to be the same numbers. But they're both negative. Because negative 3 plus negative 8 is negative 11. And negative 3 times negative 8 is positive 24. We cool? Let me make up another one. X and X. Think about the candidates, and I'll tell you what the numbers are already. They're 3 and 8. Because you can combine 3 and 8 in such a way that will give you 5, right? Negative 3, positive 8. Are we cool with that? Yeah? You like that? All right. Let me try this one. For those of you online, can you see all this, or is the glare so bad? All right. What are your thoughts here? What is it? Negative 8, positive 3. Or let's go with positive 3 and negative 8. That's the same thing. Here's a pattern that I've learned, and I just learned this. I'm sure this is in textbooks. But like I said, the best way that I learned it is I maybe did like 1,000 of these problems when I was a kid. And then I was like, hey, wait a second, there's a way easier way to do this. You notice in your trinomial, this is called a trinomial, there's 3, 1, 2, 3. In your trinomial, you have an x squared plus 11x plus 24. If I know that there's a plus here, okay, then that actually gives me a hint as to what these signs are going to be. I know that there's going to be an x here and an x here. That's a given. But the signs, what I'm talking about is either, is it plus or is it minus? Or is it plus minus? Or is it minus minus? Or minus plus? There's 4 different kinds of combinations I could have. I could have 2 pluses. I could have 2 negatives. I could have a plus minus. I could have a minus plus. Are we cool? Which 2 could it be of those 4 different combinations? It could be a positive and positive because 2 positives multiply out to be a positive number. Or it could be negative negative. So immediately, when I'm factoring this, I look at this symbol right here. And my brain says, huh, that's positive. So it tells me that those 2 numbers can be positive, positive, or it could be negative, negative, because 2 negatives multiply out to be a positive number.
But 2 negatives add 2.
So then, if I wanted to decide whether or not is it plus plus or is it minus minus, I'll take a look at this symbol right here. If this symbol is positive, then which ones do I choose? Then I choose plus plus. But if this symbol is negative, then I choose minus minus. Does that make sense?
Yeah.
So by looking at this, I can narrow it down immediately in my head. It's either plus plus or minus minus. Then I look at this and I say, oh, this will tell me whether it's plus plus or it's minus minus. Does that make sense? So it's almost like these are tricks that you've learned after you've done many of these problems. Now, if this number were negative out here, x plus something or minus something, minus 24, what can you tell me about these 2?
One has to be positive and the other is
It's got to be a plus minus or minus plus. How do you know?
negative times positive.
Because the only way I can multiply 2 numbers and get a negative number is if I multiply a positive number times a negative number. Are we cool? Then what I do is I do this. Check this trick out. I look at this second number and I see, is this a positive number? Let's say positive 5x. If it's a positive number, what does that tell me? Can you guys think of this one? This one's a little bit tougher.
Either one of them.
Yeah.
One of bigger than
There we go. If I'm adding these 2 in the middle, and they add up to be a positive number, so I'm taking a number and I'm subtracting another number, then I know, you know how there's 2 numbers that you can choose from?
the bigger number.
The bigger number has to be the positive one, because when you add them together, you're taking the bigger number minus the smaller number, the answer should still be positive. Does that make sense? So almost immediately, without even doing any tinkering, without any writing down of any of my candidates, if you give me a problem like this, I could tell you what the symbols are what signs are going to be in there. And then after I get that, it's just a matter of plugging in numbers, the correct numbers. And those are pretty easy to choose from once you kind of get a list and an idea of which numbers you can choose from. So that's how I factor. I can factor things really quickly just by playing that game. Are we cool? All right. Let's see if they have some factoring problems for us and we can try our hand at this. All right, a few more. Let's do this. X squared minus 7x plus 10. Okay. You can try it on your own. I'm going to talk my way through it. Let me just switch over to the camera. All right. X squared minus 7x plus 10. I'm going to put 2 parentheses here. Okay? I'm going to have an x and an x. I look at that and that's positive. What does that tell me? That either I'm dealing with a plus plus or minus minus. Which one do I have? Why am I dealing with a minus minus? Because the 7 is negative. Good. All right. What are the factors of 10? 5, 2, and? Come on, Chris.
Mine is class, okay.
What are the factors of 10?
5, 2, 1, 10.
1 and 10. He got 5 and 2. I was waiting for the 1 and 10. All right. Obviously, you don't want to choose 1 and 10 because that won't get you anywhere close to 7. So you would choose 5 and 2. 5, 2. Boom. Done. Are we cool? Feel more happy about factoring, less scared? All right. Check this out. If this were a parabola that I gave you, and say I asked you, graph that parabola. You would whip out your graphing calculator, put it in your graphing calculator, wouldn't you? Or you would log on online, put in Desmos, and then graph it. Or you would use the graphing calculator that I gave you and graph it, or whatever, right? I'd be like, dude, it looks like this. I'll show you what it looks like. That's what the problem looks like. How was I able to get that so quick? Because in factored form, this thing is a secret code for this. We've talked about how that is, right? And if I wanted to find the zeros of that, that would be at 5 and 2. Boom and boom. Is this a happy or sad parabola? It's a happy one because there's a positive in front of the x squared term. That's why I drew that parabola. Done. Pretty awesome.
And C, which is 10.
C is 10. That would be the y-intercept. So apparently this thing crosses up here at y equals 10.
Okay.
Something like that. Are we cool?
Yeah.
I think that this is kind of the direction we're heading in. I'll give you a parabola like this, and I'll say, graph it. Using your superpowers, not a calculator, your superpowers. Then what you would do is you would probably factor it, find out where the zeros are, plot those things in, figure out what C is, which is 10, put that thing in, and from those 3 points you can draw any parabola you want. Done. Does that make sense? The only other piece of information that might be very helpful is the vertex. Do you guys know how to find the vertex? I don't know if this is even in the scope of this class, but we can try to figure that out.
Don't you take the two zeros and get the average, and that's the x-intercept?
There we go.
I mean,
Do you guys know how to find the vertex? Sophia does. Well, I guess both Sophias do. Kind of, yeah. Do you guys know how to find the vertex of this thing? It's in the middle. It's in the middle of what? It's in the middle of these two numbers. Because a parabola is symmetric. So if it crosses here and crosses here, then right in the middle must be the middle of the parabola. Does that make sense? So what's in the middle of 5 and 2? Like 3.5, yeah? So right here. So my vertex, the x-coordinate is at 3.5. Are we cool with that? What's the y-coordinate?
You were setting up a snail aquarium at home. You're a
It's okay. Well, look, I gave you y is equal to this. It's usually f of x is equal to this. So this tells you your y value for any x value you want to give me. Which x value are we happen to be very particularly interested in? 3.5. So you can take 3.5 and plug it into here. You replace all the things where you see x's in with 3.5, and then you calculate out that number. Plug it into your calculator, figure out what it is. I don't know what 3.5 off the top, or squared is off the top of my head, so I would use a calculator. From that, you can get the y-coordinate of your vertex, and there. If I ask you for the vertex, boom, you've got it. One cool?
Then how does the vertex form?
The vertex form comes from the completing the square, which we will get to, I think, in chapter 4. And I'm pretty sure that you should have covered completing the square
Yeah, we did.
back in Algebra 1.
Yeah, that was like 2 months ago.
Was that hard?
The vertex form.
I don't even remember completing the square. That was 2 years ago.
Completing the square wasn't hard, but the vertex form, I think.
Completing the square is very systematic. It's very you just follow these steps. They're confusing steps, and I'll show you where the steps come from. You know me, I hate throwing it up on the board, but I'll show you where the steps come from. It's just this process we take things through. All right, let's try another one. In fact, before we even try them, I'm going to do this. Look at question number 5. Got it? You're going to have 2 parentheses. Draw right in your parentheses. Write down question number 5. It's x squared minus 2x minus 35. Okay? I'm going to talk my way through this. Don't worry, I'm not showing you the board because I'm not doing anything on the board. Put in your 2 parentheses, those 2 giant parentheses that you would have. Got it? What are the signs that are going to go in that parentheses? Is it a plus plus, a minus minus, or plus minus, or minus minus? Minus minus? Plus minus. You're right. Why plus minus? No.
Bigger numbers negative, small numbers positive. There's 2 negatives, so you have to multiply negative by positive.
I think you get it, but it's just very confusing the way you describe it. We know that it's not plus plus or minus minus because you're looking at that negative 35. If it were positive 35, then I would be dealing with plus plus or minus minus. Since it's a negative 35, I know that my 2 numbers has to multiply out to be a negative number, so they have to be opposite signs, plus and minus. We good? Then I look at that negative 2. The negative 2 tells me that the bigger number has to be a negative number, because if I'm going to add 2 numbers together and the total result is negative, then the bigger one has to be negative. We're cool with that? All right. We still have a lot of time, but all right. So, what 2 numbers should I choose? 17 and 2. No. I think it's like 17.5 and 2. What? 5 and what? 5 and 7. Hey, 5 and 7. That would be good.
Yeah.
Because if I can choose numbers like 1 and 35, but see, the thing is, 1 and 35 are so far apart, it won't get me anywhere close to number 2. I want to choose numbers that are kind of close to each other, like 5 and 7. By the way, which one is the negative? Is it the 7 or the 5?
7.
It's the 7. Why?
Because the 7 has to be.
Because the 7 is the bigger number, and that's the one we want to tie with the negative. So if I were to factor this, this would be x plus 5 times x minus 2. No, x minus 7. I'm sorry. Done. We did that problem. We didn't even write anything on the board. We just talked about it. Let's try this next one. Number 6, x squared plus 8x plus 16. Am I dealing with a plus plus or a minus minus or a plus minus? Or minus plus? A what? A plus and plus. Very good. Glad you finally spoke up. We don't need to go over why we did that, right? We're good? What are the 2 numbers? 4 and 4. Awesome. Write that down. All right, this one's a little harder. 2x squared plus 6x minus 80. Let's write this down. 2x squared plus 6x minus 80. Let's do that one. 2x squared plus 6x minus 80. All right. I'll be honest with you, I haven't dealt with putting a number in front of the x squared. Up until now, all we've done is have a 1 in front of the x squared. It is a pain in the butt to deal with anything that has a number in front of the x squared term. In this particular case, it's actually kind of nice to us. What I'm going to do is just this little trick. I'm going to pull out that 2. I noticed that everything's even in all of this. So I'm just going to say, well, why don't we take the 2 and put it right here? Did I cheat? If I multiply this 2 back in, it will give me exactly that. So I didn't cheat anywhere. Fair enough? Then what I'm going to do is I'm going to factor this. I'm going to kind of put my hand over it and factor this, like we've been doing. And then what I'll do is I'll just say, okay, well, the 2 is still there. So then I'll make sure to multiply my answer in the end by 2. Are we cool with that? I can do this trick because everything is even. I can pull out this constant. Or maybe if everything was by a factor of 3, I could pull out 3 out of this whole thing and make it look like there's no term in front of the x squared term. We cool? Factoring this. What am I dealing with? Oh, well, I've got an x and an x. That's true. Minus plus? How come not plus minus? Why did you choose minus plus?
I wasn't saying
I'm just messing with you. Yeah, you're right. It could be plus minus, could be minus plus. In that case, it doesn't really matter. You just happen to know that the bigger number is what? The bigger number should go here.
Yeah.
And the smaller number should go here. If you chose plus minus, then the bigger number will happen to go there. Doesn't really make a difference. What are the 2 numbers I should choose? Probably not 1 and 40. They're so far apart that they won't give me anywhere close to 3. 5 and 8. Very good. Wait, which one is 5? 5 is this one. 8 is here. Will that work? Do these 2 numbers multiply out to be negative 40? Do these 2 numbers add to be positive 3? In fact, I'll share a secret with you. You want to know how I FOIL so quickly? I just look at this. I say, okay, it's x squared minus 40, and then add these 2 numbers over here, and I'll have 3x. That's how I FOIL things in my head. Is I do basically the same understanding of things. Do you guys get it? I don't have to go first, outer, inner, last, and all that kind of junk. I don't know. After a while, you'll get used to that. But is that my answer?
No.
Close.
You still have to use the number 2.
Yeah, my hand hurts, so I'm just taking it down. And oh yeah, the 2's still there. There we go. That's my answer. We cool?
Yeah.
All right. I know. Why is nobody online in class to speak for us? Oh, that's Sophia's job. I'm going to call you out on that one. You should be speaking up for them. I'm sorry. I'm sorry, folks. Do you feel like I'm ignoring you? Okay. I apologize, Bradley. Brad, I have a question. You said that you were confused. Do you do one more? Do you want me to do another one just to make sure you guys got it? All right, let's try one more. All right, which one looks hard? Okay. Let's do this one. X squared, let's do number 8. That one looks weird. Equals 4x plus 45. X squared equals 4x plus 45. We cool? Write that down. It's asking me to solve for x. Figure out what value of x makes this expression true. So if I plug in like 2, will 2 work? 2 squared is 4, 2 times 4 is 8, 8 plus 45 is 53. Is 4 equal to 53? No, 2 does not work in this case. So the question I'm trying to ask myself is, what x value does work? Fair enough?
Can we subtract x squared from both sides? Make that be 0 and
Why don't we do this? You're right. I love the way you're going about this. Why don't we do this? I'm not used to seeing it like this. If it's all right with you, I'm going to pull everything over to the left side. And by pulling it over, I mean subtracting it onto this side. Are we cool? Sky, who are you texting? Okay, just making sure. X squared minus 4x minus 45 equals 0. Are we cool with that? All I did was I subtracted everything over to the other side. Sophia suggested that we pull the x squared over to that side. I love it. The problem is that would put a negative in front of my x squared. I don't like having anything in front of my x squared, if I can help it.
Okay.
We cool?
But wouldn't it change how the problem looks if you
No.
So now we can
Oh, I see. You're right. Let me get back to that. That's a good question. Okay. Let's factor this. X, X. What are the signs? What? Minus, minus? Wrong. What are the signs? Plus, minus. Which one's going to have the bigger number? The plus or the minus? The minus. We good? What are the numbers? 9 and 5 would be great candidates because I could get a 4 somehow. By the way, which one does a 9 go with? That one or this one? The negative. Good. All right. So 9 and 5. Man, we're getting good at factoring. It was that easy. You guys see, it's not just a game of just guessing. Oh, let's just guess 2 numbers and put it in. And we'll crack this code by just putting in random numbers. No, there's a logic behind this stuff. There's this kind of like pattern that you end up seeing after a while.
They want to know whether we have a chemistry class after.
Yes, we do have a chemistry class after this. And that starts at 2:15, I believe. What is that? 2 o'clock, I think. Doesn't it? It starts at 2:15, right?
Chemistry.
Chemistry? Yeah.
You gotta go down and get the materials.
Go run down and get the materials. All right. So we're cool with this being the factored form. We got that? If this is the factored form of this, then I can tell you what the solutions are right now. X is equal to negative 5 or positive 9. So if you actually, so let's test that out. Let's see if it really does work. If I plug in negative 5, what's negative 5 squared? 25. Equals, what's 4 times negative 5? Negative 20 plus 45. What is negative 20 plus 45? 25. So 25 equals 25, is that true? Absolutely, that's pretty awesome. Look, 9 also works, and I'll let you check that for yourselves. I think that's pretty cool. Anyway, that's how you solve that thing, and that's how you factor that thing, and this factoring is a super powerful weapon that we get to use. Are we cool? All right. Let's try another one. Because I need to finish chapter 3 today. That one looks hard. Number 7 looks hard. I almost don't want to solve it now. And so I won't solve it now. Haha. All right. So that's graphing that. Okay. Oh, I guess I do have to teach you how to factor with this technique over here. Let's try this. 3x squared minus 3x minus 18. This is where it gets a little bit tough. Did I say 3x squared minus 3x plus 18 or equals 18? What did I say? Minus 18. 3x squared minus 3x minus 18 equals 0. Is there a trick to doing this? Actually, yeah, you're
Factor
absolutely
out-
right. You can
factor out.
factor out a 3. Why is this even a hard problem? Never mind. Excuse me. Sorry. I love that idea. You know what? Instead of doing that one, can I do another problem? Because that one we already know how to do. Are we cool with that? All right. Oh, it would be good to talk about this stuff.
Yeah.
And this is actually kind of answering your question, Sophia. This is an interesting thing to talk about. Let's solve this problem real quick. 3 times x squared minus x minus 6, right? Equals 0. X squared, oh no, parenthesis, parenthesis, x and x, plus, plus, minus, minus, or plus and minus? Plus and minus. What are the numbers? 3 and 2? Which one's the 3 and 2? Yeah. 3, 2. I also need my 3 out in front over here. Okay? Equals 0. By the way, I could have just divided everything by 3 up here. Is that all right? And then divide that by 3, divide that by 3, divide that by 3, divide that by 3. It would really just look like this, wouldn't it? This is interesting. Because this is almost suggesting that it could be either this or this, and it would give me the same answer. Is that true? Well, what are the x-intercepts here? Negative 2 and positive 3, right? What does this 3 do to your graph? No.
It stretches it vertically.
It stretches it vertically. So wait, negative 2, positive 3. And this 3 over here, and my regular parabola would look something like this, right? And my new parabola, if I had a 3 out in front, like this, it would look something like this. It would be, take my black parabola and stretch it out, right? But what does that do to my x-intercepts? Nothing. Doesn't change it. Even though technically these are different parabolas, it would still give you the same x-intercepts. That's kind of going off of your question, because you were saying, well, what if I pulled the x squared over to the other side? Wouldn't that make my parabola just a negative version of the problem you solved for? And I said, that's an interesting thing. Let's come back to it. Because all you did was you said, okay, I'm going to take my regular parabola and flip them over. But the x-intercepts still stayed at the same spots. So it didn't make a difference. I could multiply this by any number I want, positive, negative, fraction. All that will do is it will mess with how the parabola looks, but it won't change my answers as far as the x-intercepts go. If I told you to solve this parabola, it would be the same solution. Are we cool? But this is not solving a problem that has an x squared or an a that's not equal to 0 or not equal to 1. Let's take a look at what happens. Oh, those are easy. All right, here we go. 3x squared plus 11x minus 4. Let's try that one. It's a little bit tougher. Is there a visual way to think about this? Yes, there is. Is that the right thing? Did I write that down correctly? Let's take a look. 3x squared plus 11x minus 4. Okay. Is there... Okay, wait, let me read some of the comments. Okay, I think we're pretty far in chapter 3. Let me look at chapter 3 real quick. Oh yeah, that's it. This is the last bit of information I need to give you. How to factor with a number out in front. And then we're done with chapter 3. Okay? All right. Is there a visual way to learn how to factor these things with a number out in front? Yes, there is. I'll be honest with you, and it has something to do with like these boxes or something like that. And you take all these numbers. I'll be honest with you, I don't find it any more helpful than just solving it, than just trying to figure it out, guessing and checking. We're cool? So, here's the added complication. Instead of having an x and an x, I can't just have an x and x because I need to multiply these two numbers to get 3x. So one of these has to be a 3. Doesn't matter really which one. And one of them has to be a 1. We cool? All right. Now, in order to get this middle number, this number in the middle, what I do is I need to add two numbers together. In the past, we just added this number and that number. Okay? But really where this middle number comes from, the one that we added together, really where it comes from is we added that would be the O and the I of FOIL. That would be the outers and the inners. We multiplied those guys together, multiplied those guys together, and then added those. That's where we got the middle number from. So that's the only other complication that we're going to have to add to this game. Are we cool? Let me show you. Which symbols are going to go in here? Plus, minus, or minus? What is that? All right. Positive and negative. Or negative and positive. In this case, it makes a difference because of this thing right here. Now, I need to choose two numbers that multiply out to be 4. And I need to choose, well, 4 is easy to factor. What are the two options I can choose? 2 and 2, 4, 4 and 1. Now, here's the thing. If I put a 2 and a 2 here, I can try that. And I'll be honest with you, the best way to solve these problems, these particular problems, is really just guess and check. It's really just try a bunch, FOIL them out, make sure you get it. What I'm going with you over now is I'm kind of going over my thought process as far as how I approach things. All right? The best thing for you to do is maybe do 100 of these problems and just like figure out these tricks that I've picked up, because then you'll own them. Then they'll be something that you understand. You made it up. You'll never forget that. If you just watch Mr. Dalday pull it out of his butt and throw it up on the board and say, this is how you do it, you might not remember it. I don't remember anything that comes out of the teacher's butts or whatever. So if I put a 2 and 2 here, I need to add that middle number. I know that these two numbers at the end will multiply out to make my negative 4, right? I designed it that way. But my question is I'm going to be dealing with the outers plus the inners. What is the outer times the outer? Negative 6. What is the inner times the inner? Positive 2. Can I add negative 6 and positive 2 in any way, or can I mess with the numbers 6 and 2 in any way to get 11? I'm talking about adding them or subtracting them. No. Then I'll tell you what, I guarantee you that it's not 2 and 2. Does that make sense? Now, let's try this. Let's put a 4 and a 1 here. All right? What is 1 times 3? 3 or negative 3? Just tell me the number. 1 times 3. 1 times 4? Can I mess with 4 and 3 to get 11 by adding them up, subtracting them, or whatever? Yeah. Oh no, 4 and 3 will make 7. That's it. So I know it's not that, but if I did this, Multiply these two numbers. What do you get? 12. Multiply these two numbers. 1. Can I mess with 12 and 1 to get 11? Yes, you can. We're on to something here. Is it this one? Is this the correct answer? No. Because remember,
Oh, yeah, the bigger number has to be
you have to add it up to be positive 11. So I want 4 and 3 to be positive 12, and negative 1 and 1 to be negative 1. Positive 12 minus 1 is positive 11. This is my correct answer. It's really just a process, a game of figuring out which numbers go in there. We're cool? And I hate to say it, there's no real secret silver bullet or secret formula or whatever. I guess I could ask Celeste, have you heard of any really good, I've been a math teacher for 15 years now. I've never seen any really good way of factoring a number that has an A term that's not 1. This thing. Have you seen anything? No. She's another math guru, so I figured I'd ask. All right. What are the solutions for x? This tells me that, if this were equal to 0, which it is, c equals 0, what are the solutions for x? What is it? I'm sorry, say it loud. Negative 4 and positive 1, close. I agree with you with that being negative 4. Do you guys remember what I said? This is saying this jump times this jump equals 0. So either this is equal to 0 or this is equal to 0. So you say either 3x minus 1 equals 0 or x plus 4 equals 0. Then you say x is equal to negative 4. I agree with your negative 4. This one you were feeling a little funky about. Well, all you do is this. You just add 1 to both sides. 3x equals 1. Divide both sides by 3. X is equal to 1/3. Or 0.333333, whatever. Anything with a line over it means keep on going. Even in this one, it's not as easy just to pull out those answers and say, oh, it's 4 and 1. Done. Yes?
So, didn't you just factor 3 out and divide both sides by 3?
If you factored 3 out, you could pull the 3 out of here, but then you would be dealing with this.
Oh, yeah.
Now, I'll tell you one thing. I've never seen anyone factor that. Yeah. I wouldn't even want to try it. I'll tell you what the answer is. It would be something that looks very similar to that. What would it be? Oh, it would be this. If you factored out a 3 first, then you would have to do that. That's what it would be. And I don't know how to factor that. Or I don't know how to factor that thing. I mean, I can tell you what the answer is going to look like. And I'm sure that I can figure out how to factor that thing. I've just never seen it done. So if you can pull out a similar term, like if this were all even, I'd pull out a 2. Or if you can pull out a 3, you know, that'd be nice. But in this case, you can't. You have to just person up. I don't want to say man up, because we've got more girls in this class than guys. You'd have to person up and just do it. You know, YOLO. All right, are we all done? That was chapter 3. Any questions on chapter 3? All right. For those of you who came in for extra tutoring, how's your brain?
Oh man, it's like dead right now.
It's been a long
I understand it, but like.
Okay. This isn't where easy speak? Is this fine? All right, good. Anyone back there? How are we doing? Yeah? I'm getting this. This doesn't instill confidence in me saying you understand. We good? All right, good. Good? Okay. All right. I feel like you get it because you're like, yeah. Yeah. We good? All right, good. Was this easy or hard? It's getting there? Let me just preview. I just want to see what Chapter 4 is all about so we know where we're going with this. So next week, Monday, I need to lecture on Chapter 4. And let's see. Your homework for Chapter 3 is basically due, I bet you it's like this week and next week. Just take a look. Chapter 3 is due, I think it's next week. Where's all that? Huh. The due date should pop up right here. Oh. It's just taking its sweet time.
So I'm trying to write down this down in my notes, and I can't really figure out how to express, like, when we multiply 3x, and then, how do you get positive 11 from 3x plus 1?
Positive 11? What? Oh. You're talking about,
I'm trying to figure out how to
you're talking about the outsides?
yeah.
That middle number, now let me explain it in just a second. Let me just, all right, here we go. Today is what, the 9th? Okay, so it looks like 3.1, 4, and 5, or 3.1, 4, and 7 is due this week. I'm sorry, I just finished lecturing on it, but at least I finished it before it's due. 3.1, I'm sure, is not that hard. Actually, I did a couple of 3.1 problems for you. That was just matching the parabolas. 3.4, we did a couple of those. I actually think I did half of the problems for you because I covered 2 and there's only 4 problems or something like that. There's 5 problems. I covered 2 of them. 3.7, we pretty much did in class today. So by Friday, you should be able to turn that in. Chapter 4, we need to get started on that. What day is the 14th? Is that a Monday? If that's a Monday, then I can only lecture it on Monday, and so I better push that one back, even though I told you I can't push anything back. You know what, at this point, if I need to push something back, what I'm just going to do is just not assign that. Yeah. Alright, let me just see what this thing is all about, though. What is this? Okay. This is chapter 4. I just want to see what this is coming up. We're done with class, and yes, we're going to start a chemistry class, and it's going to be amazing.
Yeah, but how do you, where to go on
All right, let me get back to you. Just give me a second. I'm just taking a look at what this thing is. All right. Okay, let's see. Solving. Oh, okay. So chapter 4 is solving the quadratic formula. So chapter 4, I think what we're going to do is, there it is, completing the square. So chapter 4, I think, is we're going to solve simple quadratic formulas, complete the square, probably even introduce the quadratic formula, which you should have done in Algebra 1. You folks have all seen the quadratic formula before? You guys know where it comes from? From a hole in the ground. It's magic, my friends. No, I'll derive it from you, for you folks. All right. Okay. Class is done. Don't leave because you have your chemistry class. And for those of you who don't have chemistry class, you can leave. Sophia. This number in the middle, FOIL this for me. And I'll FOIL it. Actually, I'll FOIL it. Here, watch. Okay? Sophia's asking me a question about like this. This is weird for her. Okay? if I were to FOIL this, hey, who's mom? Okay, cool. Hi, nice to meet you. All right, so check this out. If I were to FOIL this, first is 3x squared, outers is negative 4x, inners is, or negative 12x, I'm sorry. Inners is 1x, and last is negative 4. Are we cool?
Yeah.
This number is my C value, right? This number is my A value. A, C. I'm talking about like the standard equation, ax squared plus bx plus c. This is my C value. Where does the C value come from? It comes from this 1 and this negative 4. It comes from the, in the FOIL part, it comes from the L. That's, the C value only comes from the L part of FOIL,
Yep, where?
right? The A value comes from the F.
But when you factor that into 3x plus 1 times x minus 4,
This one?
how would you know that, like, those, the two factors that you chose to equal x?
I'll tell you how I knew. Experience.
Well, but how is that?
I've done this. I've done these types of problems so much that I took a look at these numbers and I immediately kind of did calculations in my head and said, if I plug a 1 here and a 4 here, all that kind of stuff, which numbers do I want to play with? Does that make sense?
But, so you would multiply 4 times 3.
This number, this is ax squared plus bx plus c, right?
Yeah, basically.
This b part comes from adding these two numbers in the middle.
Yeah.
That comes from the O and the I of FOIL,
Oh, I see.
right? Do you see what I'm saying?
Yeah.
The O and the I is here, right?
Yeah.
So that's why what I said was, to make my 11, I want to take the O and the I and see if those two numbers get me close to 11.
Okay.
Does that make sense?
Yeah.
All right, cool. You aren't in chemistry, right?
Oh, this is done.
Yo. Cool. Let's put it up on the table.
Sit all there.
Yo.
Look at that.
Oh my goodness, what? Oh. Oh, no. No, it doesn't end in 210. Yeah. Huh. It ends in 210. I messed that up. Who was that girl? Which one was that? Oh, she was sitting here?
No, the last class she came in and then she left. That's why you missed counting the people.
Oh, I don't remember. Wednesdays is just like a whirlwind of stuff for me.
Mm-hmm.
I got to start my next class. I got to stop recording. All right, I screwed up on that one.